Hi, welcome back. In this video we'll be talking about the GCD and the LCM. The GCD is the greatest common divisor. You may have seen this before as the GCF, the greatest common factor. So let's start with a definition. We're going to let a and b be integers that are not both 0. The largest integer d, such that d divides a and d divides b, is called the greatest common divisor of a and b. And we'll write d is equal to GCD parenthesis a comma b end parenthesis. So we're looking for divisors of both a and b, and we're looking for the biggest possible one. If a is positive and a divides b, then a is a divisor of a and a is a divisor of b, and so the greatest common divisor of a and b is going to be a. We'll use that later. In this course, we'll have 3 different ways to find the GCD of 2 numbers. Let's talk about the first method, the intersection of sets method. We'll define a set, capital D sub n, to be the set of positive divisors of n. So D sub a is the set of positive divisors of a, and D sub b is the set of positive divisors of b. The greatest common divisor is therefore the largest number that's in both of those sets. So it's the largest number in D sub a intersect D sub b. So let's say we want to find the GCD of 12 and 18. We need to find D sub 12 and D sub 18. The divisors of 12 are 1, 2, 3, 4, 6, and 12. And the divisors of 18 are 1, 2, 3, 6, 9, and 18. The elements in both sets are 1, 2, 3, and 6. The largest of those is 6, and so the GCD of 12 and 18 is 6. Let's do another example. Let's find the GCD of 17 and 22. The divisors of 17 are just 1 and 17. The divisors of 22 are 1, 2, 11, and 22. The only element that's in both sets is 1, so that is the GCD of 17 and 22. We do have to be careful though. In order to be able to apply this method, that means we need to know what the set of divisors are for a and for b. For these small numbers, that wasn't so difficult. But what happens if you see a is equal to 10,732? That's a bit more complicated. And we'll talk about that in the next learning objective. So that's the GCD of 2 numbers. We can also define the LCM of 2 numbers. Again, a definition for 2 positive integers, a and b. The smallest integer L, such that a divides L and b divides L, is called the least common multiple of a and b. And we write L is equal to LCM parenthesis a comma b end parenthesis. So for the GCD, we wanted to know what is a divisor of both a and b, and for the LCM, we want to know what numbers both a and b are divisors of. And there's an intersection of sets method to calculate the LCM as well. We're going to create a set. Instead of divisors, we want the set of positive multiples of n. So m sub a is the set of positive multiples of a, and m sub b is the set of positive multiples of b. Then the LCM of ab is the smallest number in the intersection of m sub a and m sub b. Let's do some examples. What's the least common multiple of 4 and 5? The multiples of 4 are 4, 8, 12, 16, 20, 24, etc. The multiples of 5 are 5, 10, 15, 20, 25, etc. We see 20 is in both of these sets, and if we kept going, we would see 40, and then 60, and then 80, etc. are in this set. The least common multiple is the smallest in this set, which is 20. Okay, what about the least common multiple of 12 and 18? The multiples of 12 are 12, 24, 36, 48, 60, and so on. The multiples of 18 are 18, 36, 54, 72, 90. The entries that are in both lists are 36, 72, 108, etc. And the smallest of those is 36. So the least common multiple of 12 and 18 is 36. Let's stop there for now. See you next time.